Hi everybody, welcome. Good morning and welcome to our webinar, Hunting and Detecting Advanced Persistent Threats with Azure Sentinel. Just a note before we start, if you have a question, please post it in the Q&A section and one of our speakers will answer it for you. All right. So we'd like to introduce our speakers for today. As an advanced security analytics global black belt, Sharon is the technical specialist for Microsoft Threat Protection Solutions, working with enterprises across APAC and GCR. Her background is centered around machine learning and its functional application in the context of cybersecurity, coupled with prior experience and understanding of security operations processes and technologies. Okay, our next speaker is Wayne. Wayne is a technology specialist at Vigilant Asia with an equal interest in offensive and defensive security. He has helped organizations across different sectors such as finance, healthcare, manufacturing, and more to secure their organizations against threats. He spends most of his free time researching offensive techniques to create better defensive strategies. Okay, so we hope that you guys will have a really fun time learning. And again, if you have any questions, please post it in the live Q&A portion and we'll get right to it as soon as possible. Now, without further ado, I'd like to turn over the time to Sharon.
Thanks, Joshua. So let me just share my screen and thank you for the introduction. Here, screen one. Yeah, it looks good on my side, so let me know if otherwise and you're seeing something else entirely different. But thank you so much, Vigilant, and for everyone who's also attending this call. Sorry, I need to turn on my video as well. Okay, so yeah, thank you for joining us. We really appreciate your hour and we do hope that you take away a lot from today's session. I'll be very honest, today I'm not going to be giving you a huge amount of information. Wayne is really the big star for today. He has a lot of great content. I'm here to give a brief introduction into Azure Sentinel, as well as how you can use our cloud native SIEM to help empower your whole SOC operations and all. So Vigilant has already run quite a few series on this particular topic, on this particular platform and technology. But just to get everyone up to speed on this, so we're all on the same page, we're just going to go through a very quick overview again, just to recap, what Azure Sentinel is. And I'll take you through in the portal, so just bear with me for 2 slides, after which I will see some of the newer updates as well. So we had Ignite in September. That is when we start announcing new features that are going into general availability, or if we're announcing brand new features that are now going into public preview. So I'll show you some of that, and you'll actually be able to look at that in your own portal as well when you do, if you do have access to your own Azure portal and Azure Sentinel. So just a bit of a background into why we even bothered to create this solution in the first place. It was really born out of a Microsoft need. So before this, we ourselves were using a traditional SIEM. We felt it was getting a bit too clunky. The fleet was getting way too big. We had to pour in so many resources just to manage the SIEM infrastructure, which, if you think about it, is really the same story that we talk about in the EDR space or in any other security solution tool, right? When you do have an on-premise based security solution tool, you actually do get very encumbered by having to deploy everything right, making sure you're protecting the asset that's meant to protect your actual resources and workloads. So we wanted to move out of that model. We also wanted to make sure that we were cloud compatible. So as we started moving more and more workloads into the cloud, with cloud, you have scale up, scale down, scale out. This traditionally does not fit very well into the legacy SIEM model, which, you had to preempt, how many EPS am I bringing in, how many GB per day am I bringing in, and then I have to start building out my clusters, making sure it's load balanced, I have resiliency, compute, storage, etc. Everything is handled well and proper for me. We wanted to move away from that model, and that's why you'll see later on that Azure Sentinel, there is very little architectural consideration that you have to put into place. Everything is handled in the backend for you. If today you are ingesting 10 GB per day, if let's say Christmas is coming and you're getting a huge amount of web traffic because you're an e-commerce site, now you're seeing a huge increase in your resources that are spinning up, etc. Even if it's just for that 2 weeks or 1 month duration where you're seeing this increase, we will scale up for you, and then consequently after that you can just scale it back down, right? So it's all automatically handled. Again, you don't have to consider how big and how you want to deploy your SIEM architecture in that sense. Just bring that data into us. Another thing that we really wanted to tackle was the lack of tools and investigative capabilities. So traditional SIEMs were very, very much focused on being a huge RDBMS, right? We'll gather all the logs, we'll shove it into tables. It was a huge and really good log management system. But when we started thinking about how does this really help me as an analyst look through all of my data, I'm looking through all of these alerts, how can I make sense of what's the broader campaign here? What the attacker doesn't just trip out one thing, right? It's not about me seeing that, oh, I'm seeing a bunch of encryption activity happening on multiple drives or multiple machines. That's kind of a bit too late. You actually want to be spending more of your time on the left side of the MITRE ATT&CK kill chain, right? So you want to look at when the attacker is doing things like reconnaissance activity, which Wayne will talk about later as well, right? When you're looking at C2 and beaconing, that's also when you're looking at C2 callbacks, you're looking at whether there's data exfiltration that could be happening as well. So looking for more of these slow and low activities, that's really where we want to spend most of our time doing this kind of high impact activity, high impact discovery, threat detection. And then the final piece is more about managing the high volume of noisy alerts. So it's not new. This was something that SIEMs were built to even address in the first place. We had a ton of alerts coming from our firewalls, our IDPs, everything on the perimeter. Then we slowly started moving into, endpoints, servers. Let's monitor all of that as well. If you had the bandwidth, you would bring in things like Sysmon, etc. Nowadays, we just bring in EDR, right? Because EDR already does that first round of triage and analysis for us. But same thing, you end up having a lot of alerts. You're not too sure as an analyst what you should be focusing your time on. We often talk about the alert funnel and how you can basically reduce the number of raw events to insights and then into actual incidents and alerts that are happening. But the big problem with the traditional model was that you are heavily limited by the amount of compute that you would have. And so that's why you typically have static threshold-based rules. These are rules that look back to the past 5 minutes, 10 minutes, maybe 1 day worth of data, and it will give you a result that says, hey, I think this person, or Wayne, for example, is trying to do some brute force activity. This rule is typically going to result in even more false positives, actually, because you're giving, for example, a blanket static threshold across your entire enterprise. I don't care if it's Wayne or if it's Sharon, and I don't care if we're both from different departments, I'm going to treat everyone the same. That's because you were limited by compute. But now that you don't have that limitation anymore, you can even do longer term baselines, right? Think about your rules in a more data-centric way. Think about how you can create baselines for different users based on different groups, how we can, especially for the topic of today, right, C2 beaconing, there's a lot that you can do in terms of looking at the frequency of pingbacks. You can also look into packet sizes, for example, looking even into ports and protocols that are rarely used across your entire enterprise. So you can at least start to hunt and look for some semblance of where you should start narrowing your investigation into. So the ability to look through and identify anomalies, to look through and identify what deviates from the baseline, that requires a longer term look back to reduce that false positive that you're prone to seeing in a shorter term look back. So just on a very high level, what we're trying to do here from the left, we're going to collect all of your data in. This is not just related to Microsoft or Azure data, right? We can bring in data from other clouds, on-premise, other security solutions, etc. As long as it's syslog, Ceph, API enabled, by all means, just push that data into us. We'll ingest that data, store it inside here for you so that you can start doing your searching, you can start writing your rules, your queries, your analytics on top of it. So this area in the top section is actually where you'll spend most of your time. where you'll be writing analytics rules. You can also use the built-in models that we already have for you. So that's Fusion. We won't go too much into that. But for the very advanced users, if you also want to do something we call BYOML, which is build your own ML, you can leverage things like Jupyter Notebooks, use some of the open source packages and libraries that you might be keen on, TensorFlow, scikit-learn, whichever. Or if you also want to use something like Azure ML, for example, to start building out all of these models, you want to do supervised learning, you want to build a neural network, by all means, go ahead. Your Sentinel data and all of the logs that you've pushed to it will still be accessible for you to build all of these models as you will. And also in the middle section, you'll notice you can start doing hunting as well. So we try as much as possible within Sentinel to make it as full featured and to make it an all-in-one SIEM. You'll see later on how we infuse multiple different features within the portal itself. So even for hunting especially, we've already curated quite a few rules that you can just run against your data, look for least common seen connections, look for rarely seen communications, etc. Use those as a good springboard and starting point to think about, how do I really want to structure my threat hunting program? Because it's not just about, running everything and looking through the results and saying, yes, I've seen how many hits. It's really structuring a more comprehensive targeted attack hypothesis, right? So if you really want to do a good hunt, and I'm derailing a bit here, think about, what matters to you. Are you trying to simulate perhaps a particular APT group, right? And you want to model after their tactics, techniques. You want to model also the IOCs that they tend to use, right? And do a hunt retrospectively within your data. That's also something you can do. So depending on how your threat hunting program is being structured, is this something you do monthly? Is this something you do quarterly? And it's a big event. You have all your different red team, blue teams, everyone coming in. Then think about how you want to best structure that and use the platform as a tool for you to help you get to where you want to be. And then the final piece is really more on the SOAR component, so security, orchestration, automation, and response. So you can do full automation as well. The minute you discover something, maybe you immediately want to isolate the machine, you want to block the IP, delete the file, etc. You can take such actions. Or if you wanted it to be semi-automated, then you can build out the workflow first and then decide after my analyst has come in, he or she has triaged the incident and they believe with a high level of confidence because they found artifacts ABC that this is a legitimate threat. I am now going to block this particular file hash from all of my endpoints and I'm going to block this IP on my Palo Alto firewall, for example. So you can choose to do that as well. Likewise, you can also use it for threat intelligence, enrichment, etc. So the sky is really the limit on that piece. So I'm going to move straight into the portal just to give you a glimpse of what it looks like. So if you take a look at the front page again, you notice that this is quite a bad example, but basically we were ingesting some data and then we turned off our instance for about a week, and then recently again in the last day, I turned it back on again, and you notice that there's nothing I need to do. It just provisions itself. I can just start ingesting data and start using my data as I will. But where I really wanted to focus on, and I'm not going to go through all of the features inside of Sentinel today, there are a lot of features, so bear with me. I'm just going to go through the key ones. When you do start to do an investigation, let's say you do receive an alert, something like URL IOC match. So this is just matching against some of the TI feeds, whether it's open source, whether it's paid, that we're ingesting into Azure Sentinel. You notice on the right side here, there is a detonation screenshot. So whenever a URL actually passes through, you can even scan it. We'll do recursive detonation and we'll show you at that point in time, what was I clicking on as a user? So this gives you a lot of context, especially because of the ephemeral nature of what attackers are using, right? If I click on a link right now, 2 minutes later, Wayne clicks on it, we might see totally different things. What I might see is a Netflix login page, and what he might see is possibly even something like this, where it was dumped right after I clicked on it, right? And so as an analyst, when you do pick up this incident, maybe even 5 minutes after the fact, can I at least know that, hey, when Sharon was clicking on it, what was she seeing? Was it a phishing page? Does it look like a drive-by download? You know, giving you the additional context so you can do proper investigations as well. That is one of the key things that we want to help you do. Likewise, as you're doing your investigations, how can you continuously expand and look into, identifying the blast radius? Who else was impacted? What else can I see? When I was doing my threat hunting, when I pulled up a bookmark, was it related to this particular case, right? So in this instance, I noticed that my admin actually started talking to a lot of anomalous organizations on Teams. So I was having conversations with wh0.com and whoever. And so now, at least with bookmarks, I can even tag and group my hunting activity together with live investigations that are actually ongoing. So this is another really cool way that you can start to really build out that understanding of what is happening and giving you a bit more context and insight as an analyst into how you can triage an incident and drive it to full closure as well. So another key thing that you can actually do within Sentinel once you start bringing all of your data in is to do data visualizations. So you can use what we call workbooks. These are dashboards, but they're interactive dashboards, right? So it doesn't have to be static representation and widgets and of data. You can actually even think about building out a graph. So in this case, my internal users are represented by the gray nodes. And then I have their external communications with other domains that I'm aggregating in these central red nodes here. So what you would typically expect in normal enterprise behavior, again, is to be able to identify, hey, there are multiple users that are actually talking to a single domain. These are partners, customers, vendors, whichever. Where I might be a bit more concerned would probably be all of these side stray conversations. Why is Isaiah talking to ese.com? Why do I have, for example, maybe down here, I have my users talking to wh0.com, Isaiah as well as admin. So maybe I do want to start looking into this, right? So you can write this as a rule. You can do it via data visualization, especially when we're talking about C2, callbacks, and beaconing activity. If you do want to do frequency analysis, that's where graphically visualizing what you're trying to do would be much more helpful than just looking at lines and lines of data. Because looking at logs itself, it's overwhelming. You can do that, of course, you have the option to do that. But if there is a better way for you to represent your data, whether through the workbooks here, or if you prefer to use Python and R, then go ahead and use Jupyter notebooks to do that. Visualization is very important, right, for you to be able to identify these very specific use cases. But I'll leave it to Wayne to talk you through more of that. So the last piece that I really wanted to show was more about the automation capabilities. So whenever you do have an incident that happens inside of Sentinel, if you attach a playbook to it, you can immediately invoke a workflow that will run, whether that's doing something simple like alerting, let's say, my SOC team on Teams, on Slack, telling them that, hey, this thing is happening. Do you want to maybe invoke some action just by replying from here? By all means, do that. You can also do things like sending approval emails, asking the users, hey, did you download this particular software? Did you know that you were sending data in the middle of the night constantly to this particular IP that you've been constantly having pingbacks to? Right? If the user said, no, I have no idea what is this, you can even from there decide to say, let's immediately reset the, let's block this user on Azure AD, and let's also maybe block this particular IP on Palo Alto. So it will automatically run. If the user says, hey, yeah, I'm doing some testing, this is intentional, I'm running a POC, then maybe you can even add their case comments in and close the ticket. So immediately bypassing and streamlining a lot of this manual labor and manual effort that goes into triaging and investigating a situation, you can consider how can you make this a bit more efficient to help your analysts reduce the amount of effort that they have to go through in order to get the response and the required information and context that they need. So maybe at this point, I'm just going to stop and hand it over to Wayne to take you through the C2 piece specifically.
Thank you, Sharon. Yeah, give me a second. Let me just shoot up my screen. So, hi everyone, and thank you so much, Sharon, for that very insightful primer into Azure Sentinel. As you know, we are conducting a series of webinars on essentially how to manage your security operations with Azure Sentinel, right? And one of the things that I felt like we had to cover, right, in this series is basically how to look and how to incorporate, these threat hunting capabilities into your SOC operation workflow, right? So for starters, right, we're going to start with command and control, right? Eventually down the line, we'll probably look at other things as well. So essentially, I mean, we appreciate that you've come and joined us in this webinar, but we also want to provide you with some value, right? So hopefully you guys can walk away with something, especially when it comes to the threat hunting side of things, right? Because threat hunting it doesn't really matter what solution you use. Obviously, you want to use a good solution that's scalable, but ultimately it's the concepts that you walk away with from this webinar that hopefully will be able to help you with your security operations, right? So I'm going to jump into my slides here, right? And before we start, I just want to give you guys a little background on Vigilant Asia. So essentially, we are a managed security service provider, right? And these are some of the certifications as well as accolades that we've achieved over the last couple of years. And one of the things that we focus on is definitely, around our security operations center. And this is where we provide monitoring service, network monitoring service, as well as, endpoint managed detection and response. So these are some of the services that our SOC offers to some of our customers. And besides that, we also have a consultancy site that does these assessments, right? We do cybersecurity assessments, penetration testing, vulnerability assessments, as well as awareness trainings for end users. So these are the industries that we're currently protecting, right? Where our clients are, right? We have customers from the financial services industry all the way to government as well as manufacturing. So we cover quite a wide range of industries, and yeah, basically that, right? So moving on, right, into today's topic, which is on, mainly threat hunting, right? And specifically hunting for command and control traffic, right? And as a primer, one of the things that we have to understand and accept, right, is that these days, security threats are evolving constantly, right? As Sharon mentioned, the techniques that attackers use these days, are pretty much ephemeral, right? 1 minute they're there, next minute they're using something else completely different, right? Switching between domains and such. And it's very hard to keep track of what these techniques are being used without proper visibility, right, into your environment. So obviously, in terms of motivation, we've got three main things, right? These threat actors they operate based off, profitability, right? Financial gain, monetary gain, and that's cybercrime. Some threat actors, more aligned with a nation state, can go for things like sabotage, as well as espionage. So there are a number of threat models here, depending on the industry you're in and what you are up against, which is why it's actually really important to also understand, who is most likely to target you, right? And what are they going to be targeting? Whether it's data, whether it's to disrupt operations. And by knowing that, at least you'll be able to strategize how you want to secure your crown jewels, right? So obviously, these groups are referred to as advanced persistent threats, or otherwise known as APTs, right? And I chose to focus on ransomware here because it's become a very, very huge problem, right? Over the last couple of months, especially, there's been an increasing amount of companies that have fallen victim to ransomware attacks, right? I think the largest, most high-profile case recently was Garmin, but there have been a number of people in the healthcare industry as well that have been affected, right? And you can see over here that the damages that have been incurred from ransomware attacks have grown pretty exponentially, right, over the last couple of years as well. If we take a look at the cyber kill chain, right, this is a simplified version, but I think it's good enough to sort of demonstrate what we're going to be looking at today, right? Attacker usually starts off with the reconnaissance phase, right? And this is where he gathers information about your assets online and, you know, the things that are the digital assets that are related or tied to your organization, right? From there, he will then move into the weaponization phase. And this is where he crafts a specific payload, right? To gain what we call a foothold within your organization. And then the next thing is obviously the delivery. This could be in a various number of ways. It could be through an email, social engineering. It could be, you know, even physical, right? Where someone just walks into your office and plugs in a USB drive and starts, infecting the computer that way. Or they could even, you know, hijack a specific, you know, those telephones, the VoIP telephones that you have these days. They're all connected to your local network, right? Someone could easily also plug in a device that could start, providing them a gateway into your network, right? So many ways with delivery, which then leads to the next phase, right? Which is exploitation. This is usually summarized and best depicted by an end user opening a malicious file. And once exploitation is done, we proceed to the installation phase, and this is usually the phase where we see attackers establish persistence in your environment, right? So if it's a malware that's running on your computer, the malware would then proceed to the second stage, which will usually, you know, involve writing some kind of registry key that ensures that even after reboots, the malware will continue to run, right? Or a scheduled task or something like that. Right, so basically this phase is to establish persistence, and this is actually one of the best places where one can actually catch threat actors, right? And basically it's the command and control phase. This is where the malware that has been deployed in your environment starts beaconing out, right, back to the attacker to continuously fetch commands, right? And I'll show you a depiction after this, right? That kind of simulates on a high level how it looks like. But essentially, once an attacker gains command and control within your environment, he can start, you know, deciding on what he wants to do next, which is basically, you know, action on objectives. If that objective is to ransom your environment, he can start, looking at ways to gain domain dominance over your Active Directory domain, right? That's one case. Another case could be, you know, as simple as data exfiltration from a specific server, right? Maybe he doesn't want to go for, he doesn't want to deploy a ransomware. Maybe he just wants to steal certain information. Doesn't matter, but the point is, at this phase is where the attacker is usually actively looking for ways to finish up his objective, right? And the key here to understanding and also utilizing this kill chain is to ensure that you have comprehensive, not just prevention, but as well as detection and response, right, throughout this kill chain. You are able to not just prevent, but detect, right? Reconnaissance, you're able to detect payloads, you're able to detect malware, you're able to detect beaconing behavior from command and control, and also, you know, if the action objective is, you know, a ransomware deployment, you're able to detect quickly that files are getting encrypted somewhere else, or whether it's, even data exfiltration, right? You're able to detect files being moved out of your environment. So this is why network security monitoring is very, very powerful, right? And it's very, very useful as well in terms of establishing a good security baseline, right? Now, moving on, right? As mentioned, you know, today's topic centers around command and control, and the reason why command and control is so important here for both the attacker and us is because the command and control is basically the channel that an attacker uses to maintain control over the assets that he has compromised within your environment, right? So assuming he compromises a laptop, one of the end user's laptop, right? The only way he can maintain control over the laptop is if that laptop is constantly beaconing it back to him to fetch for new commands, right? Command and control is also commonly referred to as C2 or CNC, right? But moving forward, I think we'll just be using the term C2 here, right? So if you hear me say C2, I'm definitely referring to command and control. There are also many different ways to establish C2 channels, right? And these are some of the common protocols, HTTP or HTTPS, DNS, and ICMP, right? These are protocols that have been around for a long time and they're part of everyone's network stack, pretty much, right? But there are also more unconventional methods, right, or channels that over the years people have, decided to toy around with, right? And these channels include Slack, Google Drive, Twitter, as well as Britney Spears' Instagram page, right? And you guys can actually Google this one because I thought it was very interesting. And there was there are live samples that were basically caught, right, of this group, this APT group, Russian APT group called Turla, right? That disguised basically your CNC instructions using Britney Spears' Instagram page, right? In the comment section of every post, right? They would leave their CNC instructions there, and basically the botnet would be able to retrieve their instructions from Britney Spears' Instagram page, right? So it's something really interesting, right? But essentially, as long as there is a way for the end user, the endpoint and the attacker to maintain bidirectional communication, it's definitely possible to establish a C2 channel, right? So this is just a quick example, right, of how a simple C2 callback would look like, right? And obviously, this is after the malware has been installed on the victim machine, right? So essentially, once the malware has installed itself, has deployed itself on the machine, the first thing it'll do is it'll reach out to the attacker's C2 server and basically start polling and asking, the server if it has any task, right, that it needs to execute. And this is essentially where an attacker can then leave a command on the server for that victim machine to fetch, right? And if the attacker says, I want you to execute, simple PowerShell commands like who am I, right? It will then fetch that command, run it, and return the output of that result back to the attacker, right? And this is basically a loop that keeps happening until the malware or the domain and server itself is effectively taken down, right? So yeah, you could think of this as just constantly happening, right? The victim is constantly polling and asking the attacker's server if it has any new operations that it requires it to do, right? Now, for today's session, there are, like I said, there are many different protocols that you can use for C2, but I wanted to specifically focus on DNS today because I think that DNS is actually one of the most ideal methods and channels for an attacker to use, right? And you see why shortly, right? Because a lot of people tell me, right, that their network is segmented properly and everything, and certain servers have no way to communicate with the internet. And while that may be true, right, the firewall is blocking that access, but you don't necessarily need direct access to the internet, right? Because if your server has DNS resolution capabilities, essentially what's going to happen, right, is that assuming this database server is the one that we have a foothold on, right, and it's the server that we want to target, right, through a DNS C2 channel, essentially what we'll do is get the database server to start asking the internal DNS server, because almost everyone has an internal DNS server, right? Whether it's your domain controller or standalone DNS server, most environments have some form of DNS server internally, right? Which will then reach out to the internet to resolve that specific address, right? So if your database server cannot talk to the internet, but it at the same time can communicate with your DNS server and resolve addresses, right? This is what's going to happen, right? So the malware will initiate and start asking the internal DNS server, where is c2.attacker.com, right? This then basically acts as a proxy, right? The DNS server will then ask the public DNS servers, right? Whether it's Cloudflare, Google, one of the big DNS providers, or even your ISP, right? It will then relay the exact same request and ask it where that domain is, right? Where is c2.attacker.com? which obviously, when the attacker sets his domain up as a name server, the public DNS will then relay that request to the attacker's name server and ask it where is c2.attacker.com, right? But the interesting part here is that the attacker doesn't actually have to reply with an actual IP address, right, to point to a specific server, right? Because what happens here in a typical C2 DNS C2 scenario is that, you know, the reply will essentially be a command, right, that is to be executed, right? So c2.attacker.com is at CMD's, you know, command who am I, right? And this will basically get relayed all the way back, right, to the database server. And because the malware understands it, right, the malware understands the response. So your internal DNS server and public DNS server might not understand what CMD see who am I is, but it's not its responsibility to anyway, right? Its main job is to just relay that request back to the original, you know, server that made that request, right? So essentially, if the malware receives the response from the attacker's DNS server, right, it basically gets the command that it needs to execute, right? And this basically goes back and forth, and essentially, you know, establishes what we call a C2 channel, right? Which is very, very interesting, right? A lot of people, you know, don't really look at the DNS, you know, protocol as something that can be used as, you know, data exfiltration, but it can, right? And as mentioned, you know, it doesn't need direct internet access, right? It can use an internal DNS server as a relay or a proxy, right, to fetch and exfiltrate data. So yeah, I mean, especially this is a very key point, right? Your servers are not truly segmented from the internet if they can resolve DNS requests, right? So if you have a server operating, I mean, within your environment right now that, you know, you think is segmented from the internet, try and see if you can resolve, you know, domains, right? If you can resolve a domain, it means that it's most likely not, you know, truly segmented from the internet, and that it's possible for it to still communicate with the internet. So after all that, right, how do we start looking for C2 activity, right? So first and foremost, you need data, right? You need information and you need logs, right? And most typically, you want logs from gateway devices, right? These could be firewalls, proxies, or even your DNS server. You know, essentially, you want logs from devices that that act as a gateway between your environment and the public internet, right? And once you have these logs, you know, you can start looking at and hunting for malware behavior, right? Malware beaconing behavior, because malware beaconing generates a high amount of traffic, right? In order for it to, you know, execute commands, it needs to go out and fetch, right? It needs to initiate that outbound connection to the server to fetch the next command that it wants to execute. So, you know, imagine if that malware beacons every 5 seconds. It will be pretty noisy, and you should be able to detect something like that within your environment, you know, if you have the right tools as well as logs to do so. Secondly, obviously, you know, all environments differ. I can't tell you that if you see, you know, a specific domain popping up more than 100 times within your environment, it's definitely malicious, right? Because the bigger your environment, the higher the average number of requests is going to be per domain, right? So it's very important to establish a baseline, right, and to know how normal traffic or how my day-to-day traffic would look like in an SIEM, right? So that you're able to immediately see some deviation, right, whenever you're performing some kind of monitoring or threat hunting. So, you know, start with the simple questions, right? Once you have all this information in place, right, start going through the information and start asking yourself, you know, what are the common IP addresses and domains that are frequently contacted within my environment, right? And is there anything that I can do to sort of, you know, whitelist them to maybe make it less noisy, right? Then the second thing is obviously, you know, monitoring the number of requests per day, right? Depending on how big your environment, right, as mentioned, bigger environments have higher number of requests, right? But if you know what the average number of requests is to a specific domain, right, then you can kind of know, you know, if something really stands out, right? And lastly, obviously, in regards to DNS, right, if you're monitoring DNS logs, you can just ask, whether or not certain workloads should even be making DNS queries, right? I put here frequent, but sometimes, is it really even necessary for an internal database to be making DNS queries? And should you be creating a rule, right, that immediately flags the second you detect a DNS query coming from that specific machine? So, these kind of things are things that, you should be considering, right? Especially, if you're trying to establish a baseline, right? And lastly, you can also utilize the threat intel feed, right, to look for known malicious domains. So obviously, attackers can change their domains anytime, but by utilizing, a threat intel feed, you don't have to cross-reference as much, right? You don't have to continuously look up for, information about a specific domain and do manual investigation in that sense, right? You can basically obtain, many feeds from open source options, right, that are completely free, and you can start utilizing that data within your environment, right? So I'm going to hop into demo over here, right, which is basically just a really quick one, right? And Sharon mentioned earlier about the workbooks, right? And essentially in Sentinel, a workbook is basically a dashboard, right? And the workbooks in Sentinel are very, very customizable. It's one of the things that I love about Sentinel, right? I can, put up all kinds of visualizations. I can lay them out however I want. And I don't have the example here, but you can even use a map, right? If you want to see, where these domains are resolving, things like that, right? There are a lot of cool things that you can do with workbooks in Sentinel. And this is a pre-built DNS workbook, right, which basically gives you an overview, right, an immediate overview of how your environment looks like. So I'm just going to do a quick refresh, right? And, just by looking at it, you have an idea on what the average baseline is, right? In this example here, I only have like about a day's worth of data, right? But imagine if you have 30 days worth of data, right? You'll be able to see spikes like this pretty easily, right? And then you can start investigating why these spikes are happening. Right, they serve as a very, very good indicator as to indicators of compromise. Right, it's not necessarily always a true positive, but it's something that you can start investigating. Right, and then over here, we even break down the top domains that you've queried. Right, these are fully qualified domain names. Right, so the FQDNs, and you can see which are the most consistent FQDNs. So sometimes this is very useful for HTTP beaconing, right? But not so much for DNS beaconing, right? So we didn't cover HTTP today, but it's similar approach. The concept is exactly the same. It's just that it utilizes a slightly different network stack, right? But this is another one that's interesting, right? Unique domains query. So how many unique domains do I query on a daily basis, right? And is it possible for me to draw a baseline here, right? So let's just say on a daily basis, I query about, about 1,000 or 2,000, or even maybe, within the hundreds, right? But out of nowhere, I suddenly see a spike that, says that I've queried 10.5 thousand unique domains in a single day. And that is definitely, a sign of malicious activity, like if you ask me, either that or some application is horribly broken, right? But it's definitely worth investigating. And yeah, quick baselines, right? Quick baselines for you to see. And then we have another thing called domain entropy. And entropy is basically a representation of how random a specific thing is, right? So if we're talking about the entropy for a subdomain, it's how random does the subdomain address look like, right? And we can see over here, this one over here, mail-microsoft.co, has a pretty high entropy count, right? It's red, and you can see that there's a large number of subdomains that have been queried, right, via this specific workbook. And these are some of the addresses, right, that you can quickly see, right? Obviously, it's not advisable to do your investigations here, and I'll move into the next section to show you how you do your investigation. But before that, if you see domains like this, right, they're generally not, I wouldn't say they're too innocent, right, and definitely worth investigating. So we can take a look, right? We can take a look, and basically this is Sentinel's querying page, right? This is where you start querying the data that you have within your SIEM. And the language they use is called the Crystal Query language, and it's actually really, really simple to use. So in this specific query, I'm basically taking all my DNS events, and then I want to get a count of each. I want to get the count of each parent domain that has appeared in this list of events, right? And then I want to sort it by the descending count, right? So if we run this, you can see the amount of queries that have been made, right, to all these respective domains. So you can see, you know, we have a few common ones here, right? We have Azure, we have Twitch, we have, you know, Taboola, Akamai, Reddit, and such, right? Relatively benign traffic, but, you know, almost immediately you can see that this number just sticks out like a sore thumb, right? Obviously, this number in a large environment may not mean as much, but still, I think that it's a relatively high number, right? So obviously, in the larger environment, your average queries per domain would probably be much higher, right? But yeah, as mentioned, this is definitely worth taking a look at, right? And we can see over here, you know, there were 19,000 queries made mail-microsoft.co, right? Now, the next query I'm going to run is basically just to pull all the events that essentially were pointing to mail-microsoft.co, right? And this is where we can basically start investigating, right? At least very quickly, get a feel of really what is going on, right? And if we open it up here, you know, we see that a lot of these queries, right? Sorry, before I go there, a lot of these queries were CNAME queries, and generally, I don't think a single IP address, right, would be making that many CNAME queries, right? Because CNAME queries are not that common from end users' perspective, right? Most of the time, you see A queries or quad A queries, right? Quadruple A queries for IPv6, but CNAME queries, right, on a normal end user's IP is pretty rare, right? I'd say, and you can see that there are many different domains here, right? All kinds of domains, and they're constantly changing, right? If you notice, I'm going to open this a little bigger, yeah, in case you can't see, please. You can see that, you know, this specific subdomain has a rather high entropy rate, right? It's kind of random. It doesn't really make any sense. And, you know, but one thing it's consistent is that it's consistently pointing to this FQDN, which is totally not c2.mail-microsoft.co, right? And from there, you know, you can get a gauge, right, as to what's really going on. And there are many other ways, right, that you can proceed with this investigation. Obviously, the first thing is you really want to go take a look at this computer, right, on this specific IP address to see, you know, what kind of processes are running on this thing that's making that many queries, right? The other thing that we can do, right, in order to validate, you know, suspicions or whatever, or like catch low-hanging fruits, right, things that, you know, malware beaconing towards known malicious domains. And essentially, this involves the use of a watch list, right? A watch list is basically a list that you maintain. It could be for anything. It doesn't have to be for just malicious domains, right? It could be for assets, right? Specific bunch of assets. Just think of a watch list as basically a list for, you know, to group a bunch of things together, right? In this case, I'm grouping a bunch of blacklisted domains, right? And I can run a query that basically, you know, takes whatever DNS events I have and compares that with any of the domains in a watch list, right? And if I run this, you know, you'll be able to see that it immediately picked up, you know, this mail-microsoft.co domain, right? All these domains are being flagged as, you know, malicious, and this is actually one of the ways you can create rules within Sentinel as well, right? To basically automate the detection portion of it, right? So you don't have to continuously run it. You can set this up as a rule so that it constantly runs every, you know, set interval, over a set interval, and, you know, you get the information that you want. Now, before we move on, I can show you a quick sample, right, in case anyone's still interested on in C2s. The way how this C2 works is essentially it passes in the commands as well as the response, right, through this through this first part of the domain, right? Which is why you see constantly changes, right? And to show you an example, this is the shell that I have on the victim machine, right? And if I issue a simple command like, who am I? Is it dead? It might be dead. Right. Right. So if I run something, I'll run something long, right? So I'll run a dir, right, which basically lists the folders in the current directory, and yeah. So now it's returning the response, right, of the output of that command, right, which is basically all the directories within this specific folder, and you can see it's receiving it bit by bit, you know, and that's basically because it has to break up the DNS request into multiple DNS requests, right? So over here, I'm just going to run the query again, and you can see, right, suddenly there are extremely long domains, right, not so short, right? These are the short ones, and then you have the longer ones over here, and these are basically domains in addresses in hex format. So if we go over here, right, if we do a simple conversion, right, from hex, you can see that this is half of the output, right, or not even half, maybe like 10%. And then we can look at, you know, other queries as well, and just keep pasting them in here so that you can see, right, even more dates. So obviously in this scenario, this traffic isn't encrypted, right? An attacker can easily encrypt this, and there is no way that we'd be able to, you know, see what's actually going on. But, you know, in this specific case, you know, in order to show you how this really works, this is basically how it works, right? The malware will fetch commands from this C2 server, and then it will return the commands using this really, really long address, right? Which the C2 server will then be able to understand and convert it into the output that you see over. Yeah, I think it died again. Yeah, sorry about that. But yeah, I mean, you saw the output over there just now. So basically, that's where the output came from. So finishing off, right, as we're nearing the end of our session, right, I just, you know, hope that you guys walked away with something today, right? Hopefully you guys, seen some of the things that attackers are using these days. And yeah, trust me when I say that C2 is really the thing that you really want to be looking for. You know, I understand, like, you know, making sure your endpoints are secure and all are important, but if you have no network security monitoring, it's very, very hard for you to detect, you know, malware that's already prevalent or, you know, spreading within your environment. So definitely look at incorporating some form of network network monitoring on your network stack at least, right? And to close off, right, if what you saw today interested you, and it was something that, you know, you think that you want to, you know, have in your environment, or at least experiment within your environment, we're basically offering what we call a security workshop, right, which is you know, deployment of Azure Sentinel, as well as a few other Microsoft security solutions within your environment, and we'll leave it there and we'll monitor the data for about 2 weeks. And at the end of it, right, you will basically get a report which highlights what we found and the things that you can improve, right? So this is a very, very useful workshop in terms of establishing, you know, where your gaps are currently, right? And some of the things, you know, that I showcase today can be performed within your environment as well. Sentinel is a huge part of this workshop, right? And we'll be able to sort of create detection rules, right, based on the events that we've seen, you know, within your environment. And, you know, all of this will essentially be consolidated into a very, very nice report, right, which you can then get customized, you know, use this customized report to then present to your, you know, board or management if you need some kind of justification for a budget, right? This security workshop is free, right? We are happy to do it for our customers, right? And think of it as kind of like a demo, a POC, right? A pilot for Microsoft security solutions, and, you know, how basically Microsoft solutions can really, really help, you know, provide you with that coverage, right? We talk about the kill chain, right? The Microsoft security stack is able to cover you, end to end, right, throughout the kill chain, and it's definitely something that, we wanna be, implementing within all our environments, right, in order to improve the security posture of the organization, right? So yeah, I mean, that brings me to the end of our presentation. If you guys are interested in the workshop, feel free to reach out to Josh or or just leave a question in the chat, right?
Hey, thanks, Wayne. Thanks for sharing.
Welcome.
Yep. So we're gonna leave the next couple of minutes open for for you to ask your questions, and we're gonna make our speakers just wait for a little while. And if you have any questions or you want to talk about a POC for your company, please drop your request in the Q&A section, and we'll reply that right away. Otherwise, thank you for your time, and we'll see you at the next one. Okay, so we've got a question here. How is this different to others like PRTG and SolarWind? Sharon, if you are free, maybe you want to take that question.
Yeah, sure. So I'm not too familiar with PRTG. Let me just do a quick search on that. But especially for SolarWinds, it's mostly focused on being a log management tool. So it's great at bringing in data. It'll push it into the tables for you. But depending again on your use case, so it's not that you have to have an SIEM. It's whether you need to have an SIEM. And the big difference between an SIEM versus an LMS, a log management system, is the additional capabilities that you get in terms of being able to run analytics rules with huge compute, right? So even with LMS systems, yes, you can do some form of rule writing, throw out some alerts, but you're going to be heavily bogged down by the lack of compute capacity, as well as not so much storage, but the intelligence within it as well. So inside of an SIEM, you would typically have many more features. So whether it was the workbooks that we showed you earlier, the dashboards, being able to run hunting queries, all of these SOAR capabilities as well, kicking in workflows, etc., having this whole investigative experience, UEBA, threat intel platform that we didn't even go through today. All of those features are actually available in the SIM side of things, not so much your LMS side of things. Yeah.
There's also another question here. Would like to confirm for Azure Sentinel, we would have to subscribe to Azure Defender first.
Oh, no, you don't have to. So there are two separate products, each covering different, not agendas, but covering different workloads in a way. So Azure Defender, I'm not sure if we're talking about the same one, right? Azure Defender, which used to be Azure Security Center premium tier, has now been renamed into Azure Defender, and there's 7 types of Azure Defenders. So there's Azure Defender for servers, and then you have it for IoT, for SQL, for Key Vault, for there are a whole bunch of things. So there's a lot of different types of Azure Defenders. If you're talking about Azure Defender for servers, for example, that basically gives you 3 things. One is you get the compliance, regulatory compliance view over your different resources. Second thing that you also get is EDR capabilities, so you can install our EDR. You are entitled to that when you register for Azure Defender. Likewise, the last piece is vulnerability assessments. So you'll be able to see, for all of these different servers and IaaS that I have, whether it's in Azure or not, whether there are any vulnerabilities outstanding. So you can tie in together your threat plus vulnerability management side of things. So that's what Azure Defender is focused on, a very specific type of workload. So Azure Sentinel sits one layer above it, wherein you are saying that, hey, now that I have Azure Defender, it's doing great. It tells me some things. It gives me some alerts as well. How can I take this into a broader context so I can say that, hey, maybe this is also linked to, for example, something I'm seeing on my network. So correlate your endpoint together with your network, or if you're having a hybrid environment, how can I take a look at maybe Azure Defender, you're only using it to cover your Azure assets, but maybe you have another tool that you're using inside of AWS, let's say your guard duty or whichever, and you want to correlate the two. That's what you would do inside Sentinel. So Sentinel will ingest the data from Azure Defender, but if you do not have Defender, that's also okay. How do we handle alerts? Can it be customized to send out SMSs or apps? Yes, so just now remember when we saw that workflow where you can kick in multiple different steps, it is up to you. So if you want to send an alert to something like a case management system, ITSM system, ServiceNow, if you're using something open source like the Hive, that's also something you can kick it to, Jira, whichever, we support that. If you want to push it to a communication system, meaning something like Teams, Slack, email, if you want to send it out to via an SMS, you need to ping either an SMS gateway that you might be having or that you are hosting yourself, or use something like a Twilio, right? So those are other vendors that also help you provide this kind of SMS service. So as long as you have some mechanism to generate an SMS, then yes, just push Sentinel data and get it to kick into that particular API or however it can be accessed into your SMS gateway. The SMS gateway will then push out the SMS for you.
Yeah, to add on to what Sharon said, so in terms of the APIs, Sentinel's APIs are really, really flexible. And if you are familiar with Logic Apps, it's really easy to create a workflow like that as well, right? But in any case, Vigilant Asia is able to help you customize the workflows to your use case, right? Depending on what it is. Some of our customers want, most of the time, they want us to push it to their ITSM solution, right? Whether it's Jira or ServiceNow. So that's extremely easy to set up, and either you can do it yourself or we can do it for you as well. It's not a problem.
So I would say, and please keep the questions coming, although we are slightly over time, but it's extremely valuable to have an MSSP engaged with you through this process, because again, an SIEM is a huge Swiss Army knife, right? Whatever you want it to do, it will do it for you. It's just a matter of how do you want to get there, and is this the most efficient and way to get there, and what's the best practice? What else are other people doing? Because it is a huge blank slate. Today, Wayne showed you about C2 and beaconing. this is just one use case of the many use cases that you can explore, right? Data exfiltration, if we talk about that, there's data exfiltration through so many means. Are we talking about USB plugins? Are we talking about to cloud endpoints? Is someone dumping all of your data into an S3 bucket or Dropbox, etc.? There's so many different attack vectors and points from which you can cut off and identify things that are happening. And so it, more so than the technology, I really hope everyone from today starts thinking about the process as well as how you want to get there. And honestly, having a partner in there to help you through this process is super important. Yeah.
All right, thanks guys. I think there are no more questions. Thank you so much everybody for participating and asking questions. If you have any further queries or you just want to talk to us, please email us at info@vigilantasia.com.my. I would like to thank our speakers. Oh, we have one more question here. I'm going to publish it. Right, so if anybody wants to take up that question.
Sure, I'll take it. Yeah, so the workflow can be smart enough to customize on the action side, say blocking the traffic, or correlate with a network security gateway to apply rules automatically. So essentially, the workflow is entirely dependent on the solutions API, right? So for example, if we're talking about Azure network security gateways, right, or network security groups, sorry, NSGs, Azure has APIs, which allows us to block IP addresses off the fly, right? So exactly like you mentioned, essentially, if we detect brute forcing activities on the RDP service whatsoever, and an alert is generated, we can tie a workflow to that specific alert, which will execute as soon as the alert is generated, right? And the workbook will, I mean, the workflow will then take the IP address from that alert and make the necessary API calls to Azure to block that IP address, right? So in terms of what it's capable of, it's really, really huge, right? The scope. I mean, as long as you have a solution that can provide a pretty comprehensive API that allows us to do responses, right, through it, that includes blocking, allowing, whatsoever, we're able to integrate that, right? So the most important thing here, I'd say, is whether or not the solution supports the action that you require us to do through an API, right? Because as long as it's supported through the API, we can do it.
All right, I think that's it, and that's all the time we have for today. Thank you again for coming, and if you want to contact us, please do so at info@vigilantasia.com.my. Thank you, Sharon. Thank you, Wayne. And we'll see all of you the next time around. Thank you so much.
Thanks, everyone.
Thanks, Sharon. Thanks, Josh.